A very good morning, class 12. This is Sana Uzma from the Millennium School. In today's session, children, I'll be discussing with you some questions which are important for your board examinations, the theoretical questions which you get in your board examination from this chapter. And in the last session, if you remember, I discussed with you the concept of molecularity and also compared it with the concept of order of the reaction. So if you have seen or if you have been following the video sincerely, you'll be able to answer the questions that are mentioned today. So after noting down the question, children, you can pause the video and you can try to write down the answers on your own. So if you remember, in the last video, I concluded with a question, that is why molecularity cannot be more than 3, and then I gave you a hint also to solve this question. So I hope you tried this question and many of you have sent me the answers also, and it was correct also. So now I'm going to answer the question for those who have not done it or who were not able to write the proper answer for the question. Now the first question which is important for your board is, why molecularity can never be 0? If you remember, children, in the last session I told you that molecularity is the number of molecules colliding together efficiently to produce the product. So obviously, if there is no molecule, molecularity 0 means there is no molecule at all, and when there is no molecule, obviously there will be no reactant, that means no product formation. So molecularity can never be 0. So what will be the answer for this? Write down that molecularity can never be 0 because at least there should be one reactant to react and produce the product. So molecularity cannot be 0. I hope the question answer is clear to you. Now moving on to the next question. The next question is, why molecularity cannot be more than 3? So molecularity cannot be more than 3. The answer to this is hidden in the collision theory. So you have to consider here what? Collision theory. The answer is according to collision theory. Okay. So what does the collision theory say? The collision theory says that for a reaction to occur, it is necessary for molecules or the reactant molecules to undergo effective collision. And one more thing, all the collisions are not effective. Only the molecules possessing or colliding with suitable energy and in suitable orientation will be able to produce the product. So according to collision theory, the molecules should collide effectively to produce the products. So you can see the answer is mentioned here. The probability of simultaneous, note this, the probability of simultaneous and effective collision of 3 molecules is very low. So even 3 molecules could not collide properly or effectively in most of the cases. Hence molecularity cannot be more than 3. So thinking of molecules, more than 3 molecules coming up and colliding together effectively to produce the product is impossible. Okay, so while mentioning the answer, you need to point out this, that according to collision theory, because the answer, the key word to the answer is collision theory. So here you can see that if suppose two balls or two molecules are colliding, the collision can be effective. Obviously they can easily collide with each other. Okay, and if 3 are colliding together, they should come in close contact with proper orientation, that such that all the 3 molecules are capable of hitting each other with proper energy and proper orientation simultaneously. So molecularity can be 3. Okay, but when you are talking about 4 molecules coming together and colliding and touching each other at the same time is not possible. Therefore molecularity cannot be more than 3, because what should be the proper answer for this? According to collision theory, the probability of simultaneous and effective collision of more than 3 particles is not possible. So I hope the answer is clear. Now you can see an example is mentioned here. Nitrogen is reacting with hydrogen to produce ammonia. According to the theoretical concept, since the molecularity is theoretical concept, you can see here 3 hydrogen molecules and 1 nitrogen molecule is reacting together. So according to this reaction, the molecularity should be 4. But as you have come to know that molecularity cannot be more than 3, obviously the molecularity 4 is not possible. So the maximum molecularity which is possible, even being a theoretical concept, is 3 only. So when you see that in a reaction the number of molecules which are participating is more than 3, then the molecularity will be 3 only. It can never be more than 3. Please do remember this, children. Okay, molecularity can never be more than 3 because effective collision of more than 3 molecules or particles is not possible according to collision theory. Now another very important board question is differentiate between order and molecularity. This also maximum of you are aware of, and you can write the answer on your own. Though I have mentioned the answer also for you here. So I hope you will agree to the points mentioned here and you are well aware of the points. So the first point of difference is order is a experimental concept, that is order can only be deduced experimentally, whereas molecularity is a theoretical concept. Molecularity can be calculated theoretically, though you need to keep this in mind. Even being a theoretical concept, more than 3 molecules cannot collide together to produce the product. So molecularity at the max can be 3 only. Now order, it is defined for both elementary as well as complex reaction. Elementary, children, I told you the meaning of this term. Elementary means single step reaction, whereas molecularity is only and only for single step or elementary reaction, whereas order can be determined for elementary and complex reaction. Order can be negative, 0, positive or fractional. This I have already told you, but molecularity is always positive. It can neither be 0, it can neither be fractional, it can neither be negative. This is not possible. Whereas order can be any of these. Molecularity is always positive and it can be either 1, 2 or 3. Okay. Why it cannot be 0? I have already explained you. Why it cannot be more than 3? This also I have explained you in the form of a question. Then why it cannot be fractional? Because a molecule will go and collide as a whole. It is not possible that just half of the molecule or 1/4 of the molecule is going and colliding or hitting the other particle and the rest remains at a place. It is not possible. The molecule will move as a whole and hit the other particle. So again the molecularity cannot be fractional. Then you can see here order can be greater than 3. Obviously it can be 3, 4, 5, 6, there is no limitation. But molecularity can either be equal to or less than 3. I hope this is clear to you. So this was just a revision of the topics that you have done in the previous sessions. And these are the proper notes you can jot down in your notebook because these are important questions also. Now coming to a numerical for the revision purpose. You can see here, children, an equation is mentioned here. Now what you have to do is the rate of formation of NO2 is given as 2.8 into 10 raised to the power minus 3 molar per second. For moles per liter you can also write molar. Calculate the rate of disappearance of N2O5. This is the question and I have already discussed a similar question with you in my previous sessions. So rate of formation of NO2 is given to you and you have to calculate the ROD of N2O5. So first of all, if you remember, I told you whenever you get such type of question in your examination, what will be the first step that you'll do? You'll write the rate in the terms of differential rate law as it is mentioned here. And if you remember, with reactants we use negative sign because with the course of reaction the concentration of the reactant goes on decreasing, and with product we substitute the positive sign or no sign. Okay, so here also I have written the reaction the same way, and these stoichiometric coefficients move to the denominator part. Here also you can see all the stoichiometric coefficients are written in the form of denominator. Therefore, this can be written as, now you have to relate N2O5, because your question is to find out the rate of disappearance of N2O5. You will have to consider this, and this is the given part in the question. So I am correlating these two. This 2 has been migrated to this side, so you'll get the reaction or the equation as minus D N2O5 concentration upon dt, which is equal to 2 by 4 dNO2 upon dt. So you'll get the answer in this form. And as I told you, the rate of disappearance or rate of appearance is never mentioned with negative sign. So the answer will be mentioned as it is. The calculation is already done for you, and the rate of disappearance of N2O5 will be 1.4 into 10 raised to power minus 3 molar per second. So try to solve this question on your own, children, as I've already discussed such questions with you in my earlier session. So it's better if you try it on your own first, and then you can tally the answer. Now moving on to the last numerical of the day of today's session. Okay, now this numerical is based on first order kinetics. The question says, in a first order reaction, the concentration of the reactant is reduced to 1/4 of its initial value. So the point to note here is it has come to 25%, okay, of its initial value in 50 seconds. So the time is also mentioned in the question. In 50 seconds, the value has come down to or reduced to 1/4 of its initial value. Calculate the average rate constant, calculate the rate constant of the reaction. So what you have to find out, K. So you can see here, this is a direct question where the required information is given, and you have to use the equation for first order kinetics that I told you that should be used for the numerical solution is this. And from this equation you need to find out the value of K. Now substituting the value, the given values in this equation, the time is 50 seconds according to the question, and initial concentration, since it is mentioned in fractional form, you can take initial as 1 because maximum fraction is 1, and the it is reduced to, that means it is now the final or the leftover, reduced to 1/4. So I have mentioned 1/4 here, or what you can write, you can also write 100 upon 25. So both means the same. If you will express 1/4, or if you will convert it into percentage, 1/4 of 100 will be what? 25%. So if you are taking this in the percentage form, it will be 100 upon 25, or you can write it in this way. The choice is yours, whichever way you feel is easy. So this will come out to be log 4. Now substituting the value of log 4, you don't have to worry about the values of log 4. You don't have to remember, children. But this is very simple. Log 4 is simply twice of log 2. If you remember, the value of log 2 is 0.3010, and log 4 is just twice of log 2, as you can see here. Okay, otherwise even if you don't remember the boards, in your boards you'll get the values in the question. Okay, so on substituting the value of log 4, what will you get? You'll get the answer as 0.0277 second inverse. Now unit I have used here is second inverse. Now here again I am reminding you of a concept of calculating the unit. So if you remember, there was a common unit for method of calculating the unit of K. It was moles per liter raised to the power 1 minus n, and second inverse since the time is in second. So if you'll substitute the value of n here, as you can see here, the order of the reaction is 1. So you'll substitute the value as 1 here, and second inverse. So this whole term will be raised to the power 0 now. Anything raised to the power 0 is 1. So the finally what will be the unit? The unit will be second inverse. Okay, so if in case you have any confusion regarding the unit, then please use this formula, substitute the value, and you will reach to the unit. And children, please don't leave any answer in your exams without unit, because there is reduction of marks if you are not mentioning the unit in any numerical. I hope it is clear, children. So this was basically a revision session, you can say. From the next session onward, I'll be beginning with the temperature. I told you there are two factors which are very important in this chapter. One is order. We have discussed enough about the order of the reaction, and please practice some more questions from your book, children. Some boards question, and I'll keep on providing you some practice questions. And then now we will be moving to another very important factor affecting the rate of reaction is temperature. That is also very interesting, and I hope today's session is clear. Copy down these questions in your notebook and properly maintain your notes. As I told you earlier also, keep on writing the notes along with the video, because self-made notes are always better than the notes which you borrow from your friends or you download from here and there. And the notes which you prepare on your own is always more useful, more comprehensible, and more easy to understand. Okay children, thank you for watching the video. Take care.